Another important word when we're describing waves is intensity, and this one's quite easy to relate to because the intensity of light waves, we experience that as brightness, and the intensity of sound waves we experience as loudness. So if I see a brighter light, that means the intensity of light waves hitting my eyes is higher. And if I hear a louder sound, that means the intensity of sound waves hitting my ear is higher. Okay, but what actually is intensity? Well, it's this idea of it's the intensity of sound waves hitting my eardrum. It's how concentrated the power is. So the power, that's the total energy per second hitting my eardrum, and then this is the area of my eardrum. So it's how concentrated the power is. But I'm not going to focus on that formula here because there's another formula that you need for intensity. The intensity of a particular wave, a single wave, is directly proportional to its amplitude squared. So I've drawn a wave here. I'll make it a displacement time graph. So the amplitude of this wave is 2 meters. Now, the intensity is going to be directly proportional to the amplitude squared. That means it's equal to some constant times the amplitude squared. Now, that constant depends on what kind of wave it is, what material it's travelling in, etc., etc. So if you're looking at sound waves in a question, then you're going to need to work out what that k is. Okay, but for my wave here, the amplitude is 2 meters, so that means that its intensity is equal to some constant times 2 squared, so its intensity is equal to 4 times the constant. Okay, so have I got number 3 now? Okay, so we're not going to change the frequency, so the time period has to stay the same, but we're going to double the intensity. Now, intensity is directly proportional to amplitude squared. So if we double I, we double A squared. Now, what does that mean needs to happen to A? Well, that means that A needs to get root 2 times bigger. And the amplitude in this wave is 0.3 millimeters. So that means the amplitude in the new wave is going to be root 2 times that. So that's 0.42 millimeters. And so there's our wave. Same time period, same frequency, but with the amplitude root 2 times bigger than before.